lithosphere. This is your essential standard 2.1, and this is your overreaching unit that will include several parts. And it'll be things like the layers of the earth will be one. And then that will lead us to earthquakes and volcanoes. Because once those layers of the earth get some plate tectonics on them and they start floating around, you're going to get some earthquakes. And then eventually you could also get, or we're also going to study, volcanoes. So all of that's going to go in this one unit. And before we can get into the lithosphere, we need to understand what lith means. So lith means stone. So if you have different layers of the earth, like the hydrosphere is the sphere of water on the earth, and your lithosphere is the sphere of stone. And sphere, obviously, which just means sphere, but lithosphere is your stone spheres. That's the stony part of the earth. So before we can get into any of those topics, we need to have a little bit of a review from the previous Unit 2. This is our Unit 3. We're going to call that Unit 3. This is part of your DIN, your Digital Interactive Notebook. This is specifically the notes on formation of the Earth. So you've got your notes worksheet. That's basically these slides with blanks in them. And as I go over these, you can fill in the blanks. But just make sure you pay attention so you understand the concept too. So before we talk about earthquakes and volcanoes and layers of the earth, we have to talk about how the earth was formed. And this is your introductory unit. So first slide is, get this out of the way, the slide that has our essential question on it. Our essential question is, how and why does the earth have different layers? And by the end of this, students will be able to describe the mechanisms that move tectonic plates. So just a little bit of a review here. In Unit 2, we did learn about the nebular theory. Nebular theory basically says that when you have a nebula, gravity will cause it to collapse on itself, and that forms a galaxy. When you have a galaxy, your galaxy will have a sun, and the sun produces radioactive rays called electromagnetic waves. The electromagnetic waves could be very, very damaging to the Earth. Luckily, the Earth has a magnetic field that protects us from electromagnetic waves. And you also need to remember that the more mass something has, the more gravitational pull it has. The sun has more mass than the Earth, so it will have more gravitational pull. Now, how did the Earth form? The Earth formed about 4.6 billion years ago, which is just a little bit older than I am. And that formed when dust and gas that was left over from the Big Bang came together by gravity, and it started spinning and spinning and rotating, and that formed the roundness of the celestial bodies. So the Earth was one of those celestial bodies, and it formed in a sphere. The moon was actually part of the Earth. It got knocked into by some space junk and knocked the chunk of the Earth out, which made the moon. It started spinning and rotating, and it, by gravity, made its own little sphere. So at this point, you should be able to answer this question. So I want you to stop and check for understanding. You can pause the video and answer the question of, explain all the factors that cause the Earth to form. You can put your answer right down here in the commenter box. Right down, where's my pointer? Right down at the bottom where it says click to add speaker notes. You can put your answer there, or you can put a text box over on the side, wherever you put it, as long as you answered that question. So pause the video and answer the question. Welcome back. Hopefully you got the answer to explain all the factors that cause the Earth to form. We will go over that in class. So what was the Earth like early on? When the universe began, the Earth was a super hot ball of molten rock. I mean, you know how hot pizza is when you eat it when it's too hot in your mouth? That's not even anything compared to rock that's melted. That's super duper hot. So it was a really hot molten ball of rock. the heat was from the friction of all the molecules and radioactive elements and just explosions. So that's what the Earth looked like. It was molten. It was liquid, a spinning hot liquid ball. So why is it not molten now? Well, space is very cold. It is a very, very, very cold place. So all that molten rock would eventually, over 4.6 billion years, cool down. The surface cooled down over millions and millions of years. It did take a long time for that surface to cool down, because all the heat had to be absorbed out of the Earth into space. So is the Earth all the same? It is not homogeneous. It is not all the same layer, all the same material. The heavier stuff is pulled towards the center by gravity. So it's pulled towards the center because it's heavier. So it causes more gravity, has more gravitational pull. So your nucleus, the core of the Earth, would have more gravity. Not more gravity, it would be heavier. So we also have different layers. Because of the layers that formed as they cooled and settled out, you have different layers. Some of them are liquid, some of them are solid, some of them are solid liquidy kind of stuff. So we're going to talk about those in just a second. But before we do that, we're going to need to check for understanding again. So I want you to pause your video in just a second and answer the question. Explain how the different layers of the Earth were formed. So you should be able to explain that. Remember, put it down in your speaker notes box or on the side, wherever you want to put it, as long as you answer it. So pause the video and answer it now. Welcome back. Hope you got that one right. We're going to go over that in class. I did say we were going to talk about the layers, and here they are. The lithosphere, remember lith is stone, the lithosphere and the upper mantle, which is the part at the top, like on the outside. We are standing on the lithosphere, the crust of the lithosphere. So the crust is on the very outside. Right under that is the lithosphere. And then the upper mantle part. The mantle is liquidy. So it's the upper mantle part. Like if you have a chili, when you have a piece of cheese on the top of it, the piece of cheese on top would be the crust, and the chili underneath would be the mantle. Now the outer core, so we're going in from the outside. Under the lower mantle would be the outer core. And then inside the outer core is the inner core. And the inner core is very, very solid, and the outer core is liquid. But we'll talk about that in just a second. You might want to stop and sketch a diagram of this in your notes or on a piece of paper just to practice. That'll help you understand which layers are which when you label them. So what's the lithosphere and the upper mantle like? Well, the lithosphere is crust on top of the mantle, like I just said in the last slide. It's cool and it's rigid. I mean, think about it. If you're standing on the ground, it's rigid and it's cool compared to the core of the Earth. And right below that's the upper mantle. And the mantle is kind of like a cheese sandwich. If you're looking at a grilled cheese sandwich, the bread on top would be the upper mantle. The bread on the bottom would be the lower mantle. So the upper mantle is hot and it's semi-melted because of all kinds of pressure and friction. It's really hot and it's semi-melted. Here is where your lithospheric plates float on top of it. So you have the upper mantle that's liquidy, and you've got this hard, solid crust and lithosphere that floats on top of it because it's less dense. So what's the lower mantle like? The lower mantle is even more hot, and it's semi-rigid, but it can still flow. So the upper mantle is semi-fluid, semi-liquid, and the lower mantle is semi-solid, semi-rigid, but it can still flow. It's really hard and rigid, but it can still flow because there's so much pressure. It changes, kind of like oobleck, your non-Newtonian fluid. When you get cornstarch and water and mix it together, it'll become solid until you put just enough pressure on the surface area, and then it becomes liquid. If you've never done that, you definitely want to try that experiment with your parents' permission, of course. It's pretty fun. So at this point, we're going to check for understanding again. Students should be able to explain the relationship between the lithosphere and the upper mantle. And how could these two interactions affect humans? How could they affect us? So I want you to pause the video and answer that question in the speaker notes or on the side in the text box. Welcome back. We're now going to talk about what the core is like. So we're going from the outside in. We're at the core now. You have the outer core, which is liquid metal. It's metal. It's liquid. There's a lot of friction and a lot of pressure. The inner core is solid. There's so much pressure and so much heat. It made it solid. It's a completely solid ball. And that is due to pressure, like it says here. So how do these layers affect us? The core is magnetic because it has that metal in it and it's solid. It's magnetic. And the interior of the earth keeps us warm. So that liquidy part that's really, really hot keeps us warm because heat rises. And plate tectonics are affected by these layers because, like we said, the lithospheric plates float on top of the upper mantle because the upper mantle is liquid and lithospheric plates are solid. And because of those lithospheric plates floating on the upper mantle, the lithospheric plates can bump into each other. They can split open and lava can come forth. The bumping into each other would cause earthquakes. The moving apart from each other would cause earthquakes. The moving apart from each other would cause volcanoes. Volcanoes would cause earthquakes. So all these things relate together. So different parts of the earth affect us this way. So again, check for understanding. You should be able to pause the video and describe how the different layers work together to contribute to life on Earth. So you can answer that in the speaker notes or in a text box, but pause the video and answer that now. And we're done.